No idea what I just hit, but it looks like it's okay. All right, so let's go ahead and check in on this one. So the number, remember, on your tire is not, I have it on here as the radius. The number on your tire is actually the diameter of the rim in inches, okay? Which is fine. That's what we want, okay? So the question says, how many times does your car tire turn in the half-mile stretch of road between two stoplights? By the way, this is what your tire spinning is calibrated to your speedometer. And so how many times it spins is linked to how fast it tells you you're going. So you see people put big tires on trucks or Jeeps or stuff, and it actually changes that calibration if they don't get it fixed to where their speedometer no longer reads correctly. So it's something to consider if you change the stock tires on your car. All right, so just curious, Mackenzie, what was your R what? R17. Okay, what was yours? Is 17. Did anybody else? Yours? What did you take a picture of?
Chevy Trax.
Okay, I don't know what that is. Is that an SUV or a car? Okay. What was your R?
Huh?
What was yours?
17.
Okay. So let's use R17, and remember this is the rim diameter. Is that your tire's diameter? No? So we need the aspect ratio. So let's just whoever's was the 17. What was your P number? P what? You had a 17, right? 2 what?
60.
And then what was your aspect ratio? The slash what?
70.
Okay. Okay, so 265 millimeters. Is that what you said? Wide. And then times 0.7. That's her aspect ratio was the height. The wall height is 70% of the width. So times 0.7. Can someone do that real quick?
You did this 100% wrong.
180 what?
5.5.
Okay, so this is how tall the tire's height is from the rim to the edge of the tire. Is 185 millimeters. Okay, so we need to add 2 of those, right? Like the 17 is this, and then we have 2 185s for the diameter of the actual tire itself. Okay, so trying to get all these in here. Actually, let's use a different color for that. So what's the total diameter of our tire? Well, it's 17 inches plus 2 times 185.5 millimeters. How do you convert millimeters to inches? Well, these are things you guys should know. There are 25.4 millimeters per inch. So go ahead and convert that. How many inches is 185.5 millimeters? Do you have it?
7.5.
Perfect. So this is 7.5 inches, and we have 2 of them, okay? Like 1 on each side of the tire, I mean. So our tire diameter is 17 plus 7.5 plus 7.5. That seems a little high. Are you sure that's right? 185.5 divided by 25.4. What the heck, calculator? 7.3. We're doing 0.3. So 14.6 plus 17 is 31.6 inches. Okay. That is the tire's diameter. Why did we care about the tire's diameter for this one? Yeah, we need the circumference because the circumference, and you keep seeing me scroll past this picture, and here's why. If you've ever put chains on a tire, those wrap, like the ends are here, those wrap completely around the tire. So if we unwrap it, obviously it's a length. We could lay a tape measure down right next to that and measure a length, right? And so think about every time your tire rolls in between those two stoplights, it's laying down this much length, that much of the distance between the stoplights, right? So we just count how many of those that it takes to make the half mile, and we know how many times that tire turned. So what's that called in a circle? That length of the chain, what is that called? The circumference. Good, let's do that. Circumference. C equals pi times diameter. This is in context, so we don't want it exact with a pi in there, right? Like this is out there on the road. So we're going to say 3.14 times 31.6 inches. So what is that? Like around 100?
99.2.
Thanks. 99.2 inches. So just, it's like eight and a third feet. Every time it rolls around, her tire is going 8 1/3 feet. That's cool. In fact, we want probably to convert it to feet because I'm not going to convert miles to inches myself, right? So go ahead and convert this to feet. How do you do that? Divide by 12. So what do you get? 8.2 what?
2.6.
Thank you. Because I said it was closer to 8.3. 8.26 feet, so 8 1/4 feet. Perfect. All right, how do we figure out how many times that thing rolled around in that half mile stretch? Well, what did I tell you a second ago about miles and feet? What did I tell you a second ago about miles and feet? Yep. 5,280 feet per mile. So half of that is what, like 2640? Okay. Now what? This, by the way, is called our revolutions. So total revolutions. What do we do? What operation do we do to figure that out? Say it again. 2640 divided by 8.26 feet per revolution. And what is that? Okay, so 320 times it rotates around in that half mile. Okay. Does it matter how fast you go? Does the 300, let's call it 320, does that change based on how fast you go? Why not? It's the same distance, right? This is distance divided by distance. There's nothing in there about speed. You just would cover it quicker if you went faster, that's all. Okay? So let me just mark this if anybody references this later on. And Get rid of the 15. So that is 17 inches in diameter rim. Whoops, I did my line too far. Rim to edge of rim. Okay. Guys, it's when you know math, you can do kind of anything you want with it. It's just good, right? Good to know. Now you know, like, hey, what if we went, instead of a half mile, what if we went to Denver? Well, how many times is my tire tread going to hit the ground kind of idea, you know? Like, maybe you're like, who cares? But maybe it speaks to where and etc. You know, whatever. It's just doing math is useful. All right, let's check your homework. And let's see. I need to pull that up over here. Okay, any of those that you want to do? Or did they go well?
28.
28, okay. Let's see if I can do it on this screen. If not, we'll move it. First of all, let's write down our equation for a circle. And h in this case is 2. And y is negative 4, so it will end up saying plus 4. Okay, and then if we stick 5 root 5 into r squared, and then square it, well, of course, this left side doesn't change at all. But the 5 on the outside gets squared, and the 5 on the inside gets squared. But that's square root of 5. What happens when you square square root? It just cancels, right? So we end up with just 125. Okay, any others to do? If this was a quiz, do fist to 5 on your, like your percentage correct specifically, not whether you did it, but how many points you would have gotten. Okay. All right. I think we're good to move on then. Any questions on equations of circles? Okay. By the way, I did put that warm up in. If I say don't sit there, don't sit there. So if you did, you just got a 0 on that. And you can talk to me about making it up later on. Next section is we're stepping out of coordinate geometry and we're back into just circle drawings, circle little figures. I'm going to have these on every title slide for each section because I want you to just keep seeing these words and these concepts every time we start a new section. Okay? In this one, we'll learn, in this section, we'll learn what a segment is. That's one thing. This is called a central angle. We'll learn what it is. We'll learn a sector, the area of a sector. We'll learn arc in this section. So lots of new terms, probably. All right, take a second to ponder this. So we have a piece of wire and we're using a disc to bend it. How long does the piece of wire need to be? How would you figure that out? Obviously, we have the 100 sticking off, but how long is that second piece? I guess if we want to call it in pieces, it's not really, but how long is that? That's what we really need to find out. Whatever that is, we would add to 100. How would you figure that out? Say that again. Good. And then what? No, the wire is the black thing. So find the circumference. Why dividing by 4?
Because it's like, that's a fourth of the circumference because it's a right angle.
Do you guys agree with him? Since that's a 90, how many degrees are around that central point total? 360 around a point, right? So the 90 is a fourth. So that, do we agree with him though that the pink highlighted section of the wire is a fourth of the circumference? That seems reasonable, right? Okay. So that's one kind of example of what we'll do in this section. The pink highlighted bit is called an arc length, and an arc is that section of the circle. So basically, if we know that this angle in the center, we're going to talk about that right now, we can take that fragment or that piece of the overall circumference. Okay, we'll get to that in a minute. But good job thinking through that. So some new words, I'll go with you to the notes and write that in a second. But central angle, that was where the 90 was. We're going to learn a lot of angles, so central angle is the first one. And then we have arc, like I told you. And you see that we'll be talking about minor and major arcs. And this idea of intercepted arc. So have your highlighter so you can highlight circles. Okay, this is an angle at the center of the circle formed by 2 radii and vertex on the center. For your picture, doesn't matter which direction you make this go. So come off of the center and call both of the side lengths of your angle R. And then we'll put theta, since we're used to seeing theta as our angle variable. And that angle formed by the center with 2 radii is a central angle. And that's going to be important for this whole section. Okay, next word. Circles. I think I mentioned this, but there's a lot of vocabulary in the circles unit, so. Intercepted arc. So this is the part of the edge of the circle. Between 2 segments or lines that intersect the circle. So draw just 2 lines going through your circle. Those, by the way, are called secant lines. We'll learn that later on. And then with your highlighter, we're going to highlight that as the one of the intercepted arcs. Now, do you see how we have 2? There's one on the other side too. Or we could look at it the other way and talk about the bigger ones on the top and bottom. But just know that we're talking about a little piece of the edge of a circle between 2 lines. This can also be true if we're talking about a radius that intersects the circle. Right? So maybe if you want, you could draw a second circle. And show that we're doing this also with 2 radius as well. Like that. So either version. There's also chords that we can intersect circles with. But that part that's cut off or cut out, maybe, if you think of it that way, from the edge is called an arc, specifically an intercepted arc. Okay, so we have 2 kinds of arc. We have a minor arc and a major arc. Minor probably should indicate that it's smaller. So this is an arc smaller than a semicircle. What is a semicircle? Half. Did you know the word semi means half? So the word literally means half circle. Okay, this time, let's label these points A and B. I can make that bigger, I guess, for you. And go ahead and highlight the arc that's between those 2. And notation for this is 2 letters with what looks like an arc. Just like we've done, one thing nice about geometry is most of the symbols make sense. Like parallel has 2 parallel lines. Perpendicular is 2 perpendicular lines. Triangle is a triangle, etc. So for this, an arc is a arc over 2 letters. For a minor arc, use 2 letters. Okay, so that probably implies that we also have a major arc as well. And that's just greater than a semicircle. This time we'll use 3 letters. I'm putting it under the name so that if you reference this quickly, you'll see that. Okay, let's draw the same picture, only we'll call out the other arc instead. So the same picture that we just did, or roughly the same. We're going to call this A, that B. This time we need to put some point elsewhere on the circle, and we'll call that C. Okay, now we're talking about this arc, the one that's bigger than a semicircle. all the way around, almost all the way around. So that is arc ACB. Note that we have both in the same circle. We have the major and the minor. This is why we have different letter names so that we know which one we're talking about. So think about a problem. If I just don't draw this, but if I just give you a circle and I call out, just like we have here, and I say, what is the measure of arc? Well, I got to tell you which one we're talking about. If I say arc AB, you know it's the minor arc. If I say arc ABC, or actually it needs to be ACB, then you know it's the major arc. And so you got to know notation so you know which question I'm asking. There's not going to be highlighting and stuff that helps clarify. All right, questions on those? Okay. Doing the notation there made me realize we never defined a circle. That was dumb, huh? I should have told you that before. So I'm going to define a circle because it has its own notation. Okay? We name a circle by the point at its center. So this is circle P. And a circle is the set of all points equidistant from a central point. It's a cool definition if you pause to think about it. So all those points that are making the edge of the circle are all the same distance from that single point P. And it's the only shape that's like that. It's cool. Circles and triangles are pretty neat. So circle P, you'll see that as we work. It'll just have a circle with a dot and it will say something like circle P, okay? And now you know that means circle. All right, back to it. Sorry, I forgot to do that. Okay, so a little bit of central angle stuff. It says what is... Actually, no, we haven't defined that yet. Sorry. Let's go do that. Now, this is confusing. Each of these arcs that we just talked about have a measure and a length. And those are not the same, unfortunately. So it can be confusing. Let's do measure first. It's the easier of the two. So I want you to make sure that this stands out as measure, not length. So arc measure. Do you guys remember thinking, or not thinking, but notating measures of angles as we've gone through? Like what is, don't write this, what is the measure of angle A? Remember that? Okay, we only used that little m for angles, didn't we?
Yeah.
Okay, so same thing here. We're going to see that little m, and it's going to be an angle. So the measure of an arc is the same as its central angle. So it's degrees, not inches or feet or lengths or any kind like that. This is degrees. Okay, so I kind of made my underline too big there. It's the little m for measure, just like it was for angle. So the measure is an angle measure. It's weird. Let's finish this, then we'll take our break. It's weird because when we go talk about something on an arc, I don't need that on there. We think of it as length, but it's not. It's degrees, the measure of an arc. Okay, so on this little picture, the measure of arc AB equals 100 degrees. It's a little bit weird. How do we know it's 100 degrees? The central angle is 100 degrees, okay? So those are vice versa. Like if I know the measure of the arc, I know the angle, and vice versa. All right, we'll pause there. All right, that said, let's look at these. What's the measure of arc XZ? Just say it. It's also 115. Yep. Okay, what's the measure of arc XYZ? Okay, so that one is 115. This one, how do we get it? Yeah, 360 minus 115. So 245, and this is degrees. Make sure you're labeling it degrees. 245. Why did I write 240? I said 245. I think. Okay, so those just copy paste back and forth. Okay? Like from the central angle, I mean, to the arc. Again, this is arc measure with the little m, just like an angle. And that is the same as the central angle. Now, there's this little theorem. I think this is probably obvious, but if two central angles have the same measure, so do the two arcs. That's what that says right there on the bottom. Doesn't that seem kind of like, what's the word? Obvious, maybe? Okay. But use it as needed. All right, take a second to work through this one. You can draw it if you want, or just write down the answers. Let me know if you can't read something. The letter at the center is A, so this is circle A. Guys, as usual, just know you don't have to go in order if you don't want to. All right, it says JH is a diameter down there at the bottom. So what is the measure of arc JXH? It's not one that I listed, but that's an implication of this that you do need to know. So measure of arc JXH is what? 180, good job. So half the overall arc. Okay, anyway, with that, how do we get maybe measure of arc JE, just this little bit piece, this little bit right there? How would you do it? Yeah, good. So that little arc right there is 180 minus 60 minus 90. So 30 degrees. All right, EXC. What'd you do there? What'd you do there? That whole thing all the way around. So 90 plus 60 plus 45. And how about arc JC? Yep. 180 minus 45. That would be a good way to do that one. Are you putting your degrees on there, by the way?
Yeah.
Good. Okay, all of these were measures, just to make sure you're clear on that. How'd you do? Yeah, good. Okay. What is the question mark arc? Why? Yeah, good job. So keep an eye out for vertical angles in circles. Even if we had something like maybe this arc or this central angle is split up, that whole upper side is still vertical to this one, okay, in pieces. Okay, we can also do these. I don't know if I have one of these. I don't. So let me put one on here. We can also do these kind with algebra in them, as usual with our math. So become a circle. And okay, maybe it's like 2x plus 3, and I say solve for x. What would you do?
Two x or 4x plus 6 plus 90 equals 360.
Good. So copy, and then I'm gonna write it out, but you're right. 2x plus 3 plus 2x plus 3 plus 90 equals 360, not 180, since we're going all the way around. What is that? 60, 30, 64, I think. Can someone divide that for me? Thanks. Anyway, so keep an eye out for algebraic ones. And with that, of course, we can throw in quadratic. We can throw in multiple steps. We can throw in extra information that you don't need, etc. Okay? And then, like we just said a second ago, keep an eye out for your verticals. If we had x's in there, we could solve with those. Let's work for a bit on arc math.
Oh yeah, that makes so much. So you two know. Yeah, I see. That makes so much. Wow.
All right, let's check the fronts. You can finish up the back tonight. This will be all of your homework, I think. 10, okay. All right, here we go. Let's go ahead and check the front and then 10. So number 1 is 122, 123. And of course, these are degrees. I'm just not going to say it every time. Measure of arc CFD is 54 degrees. Number 4, 146. Number 5, 234. Number 6, 125. Number 7, x is 8. Number 8, x is negative 3. Number 9, is 50 degrees. And x on that one, x is 11. Any questions on the front?
Can you restate the 6 ones?
Yes, 6 was 125. Okay, number 10, you should have got x is -4. And the angle, central angle is 105.
Can you go back to 3, please?
To 3,
Yeah.
54.
Wait, that's, you did it backwards, cause that's the big one, right? Like,
C, F,
wouldn't it be?
D. Yeah, I didn't write it correctly. So that's, what is that?
306.
180 plus 45 plus 81. So probably everything but the 54. Okay, so it's 306 like you said. Go ahead and finish the rest of that tonight, and then grab your notes. We're going to add the next thing on there, so we can get a jump on it for tomorrow. Go back to the wire concept, wrapping around this circle. How did we find the length of the highlighted pink piece? Or how would you? Circumference divided by 4 in this case, because 90 is 1/4 of the total angle measure in the center. Okay? Guys, that's all. Arc length, you find the circumference and you just multiply it by the fraction of the total angle. That's all. So it shouldn't be surprising when we see the formula here in just a second. So arc length is a fraction of the circumference. It's the angle fraction of the total angle. What's the total angle? 360. So if it was 70 degrees, you would do like 70 out of 360, etc. And here's that formula. We'll go write it. Now, one dumb thing about this is we use the letter S for arc length, which is weird. So you're just going to have to remember S and not like L or something. Okay, we just got done writing that arc measure is a degrees thing. And now we're going to write arc length. So you can see why these two could be easy to confuse. Because arc length is like inches, feet, that kind of stuff. So just be careful, be very careful. This is inches, feet, yards, like that kind of stuff, right? Centimeters. Maybe I put the degrees for arc measure over kind of in the box. Maybe we should have written it in here with it. I'm going to do that. Okay, hopefully you won't get it mixed up. Study it a little and that will help. Okay, there's your formula for it. And let's go ahead and describe what the pieces are. That piece is the fraction of the total. And this piece is the circumference. It makes sense when you see the formula, hopefully, right? Theta out of 360, like that's the fraction of the total. And now we're saying total of the circumference. So in the picture, let's put theta in the middle at the central angle. And of course, we're highlighting that we're taking that length. Okay, this is a length now. you might need to use R to get the diameter. Now, again, we have two sides of the formula, don't we? So what if I tell you an arc length and ask you to solve for the diameter or the radius? You have to be able to plug in, so make sure you write both sides of the formula. And just as a, what's the word? Memory aid, maybe? This is the pizza crust. The arc length, this is pizza crust. The next thing we're going to write is the pizza slice. And it has a similar looking formula to this one. We'll put an example in there tomorrow, but here's what one sounds like. So in a circle with radius 4, what is the length of an arc that has a measure of 80? Now, it didn't put degrees on there, but that's what it means, right? Down to the nearest tenth. Okay, maybe draw your circle. And it says that our arc measure equals 80. And it wants to know the length of that arc. How do we do it? So S, weird, S is 80 out of 360 times pi times, what's our diameter? 8. Okay. Just, let's do this as exact for now, but, so what is 8 times 80 divided by 360? Or 8 out of 360 times 80? Can you tell me? Do 8 times 80 divided by 360. $1.78. Yeah. Yeah, that makes sense. Okay, and then go ahead and do the pi. So do that times 3.14. Now we don't have units for this, so we'll just leave it as 5.58. Okay, that was the easy version. That's when you plug in for D. Again, if I give you the arc length and asks for D, that's a little bit more work. Well, a little bit more careful work. We'll do an example of that tomorrow. All right, what time are we at? Yeah, we're good.